In this video, we're going to be answering the following problem. Find an equation of the tangent line to the curve y equals the square root of x plus 1 at the point x2. So, we are asked to find the tangent line to some curve. And we just have to remember, first off, the equation of the tangent line. So what is the equation of a line? Well, if you remember, it's y subtract the first y value, y1, equaling m, then x subtract x1. This is the equation of a line. Now, we have all the data we actually need, y1 and x1, but we don't have the m value. And that's what we're going to be finding primarily. Whenever you're asked these kinds of problems, you're always going to be trying to find the m value, mostly, and then just plugging everything in. Essentially, mind you, the m value is going to be equal to the limit as x approaches the first x value. In our case, it's going to be 3. So as x approaches 3, for the derivative, so this is another way of denoting it, derivative of f of x. This is the m value right here, all of this craziness. And that's what we're going to be using. So let me just erase that actually. You'll see what I mean when I continue working through it. So what first thing we need to find is the derivative of the square root x plus 1. Okay, now let's get started. First you need to recognize that the form x plus 1 to the 1/2 is exactly equal to the square root x plus 1 right here. These two forms are exactly the same. This is just another way of writing it, and this is the preferred way to write it in order to answer this or to find the derivative of this problem. So we're also going to be using the shortcut to find the derivative, which is, and the shortcut I'm going to be using anyways, is a multiply x, then a subtract 1. What this basically means is, if we had to find the derivative of 3x, for instance, we need to recognize that there's a 1 here, x is to the exponent of 1. So 1 gets multiplied to the front. So 1 multiplied 3 is just 3. Then it gets the 1 exponent gets subtracted by 1. That'll give us a 0. X to the 0 is just going to get rid of x. So x isn't here, and just 3 is the derivative of 3x. So that's how we're going to be using this little rule here, a little shortcut to find the derivative. So looking back at our actual problem here, the exponent is 1/2. We multiply that out front, 1/2 multiply x plus 1, and then we subtract 1/2 by 1, because that's what we have to do according to this rule, right? So 1/2 subtract 1 is going to give us negative 1/2. And if I were to write x plus 1 square rooted all over, or just under 1, this form right here is exactly equivalent, exactly the same as x plus 1 to the negative 1/2. So these two are exactly the same. There's nothing different about them, just the form. So that's what we're going to be doing. All we did was change it a bit, change this one area right here. Now remember that we're also multiplying everything by 1/2. So we multiply this by 1/2 still. And if we were to do that, we would get the final derivative of, let me just erase that, it would be just 1 over 2 multiply the square root of x plus 1. This is the derivative of the square root x plus 1. So this is f derivative. That's how you denote a derivative. You put a little prime right there. So now that we found the derivative, we're not entirely done yet, but that does get rid of, that's the hardest part essentially. All right. So now what we need to do is find the limit as x approaches the first x value. Remember, it's going to be 3. So as x approaches 3, 4, 1 over 2 multiply the square root of, then it's x plus 1, our derivative, remember? So if we plugged in 3 as the x value, we would get a 4 right there. So let me just erase all of this and put a 4 there. The square root of 4 is just going to be 2. 2 multiply 2 is just going to be 4. So the answer here, the limit is going to be 1/4. And that is equal now to our m value. So all of that mess finally got us our m value. Now what we're going to do is just plug in all the data for this equation of a line, and that'll give us our tangent line equation. So we have y, subtract y1. y1 is going to be 2. So 2 equals, then our m value we found to be 1/4. so 1/4, multiply, then we have x, subtract x1. x1 is going to be 3, so we put a 3 here. And this is our tangent line. Let me just, actually, I'll leave that there. So this is our tangent line, the tangent line equation, if you will. You might be asked to simplify this a bit, but if you usually don't need to unless they actually explicitly tell you to do that. So this is indeed our final answer. I thank you for watching. If you have any questions, just ask in the comment section below or PM me. I'll do my best to answer your question. And I do hope you're having a fantastic day.